Okay, for question 13, it says Pam has to deliver containers of food. Each container weighs 50 kilograms to the nearest 5 kilograms. The maximum load for her van can carry is 1,500 kilograms measured to the nearest 100 kilograms. What is the greatest possible number of containers that Pam can carry in her van? So the first thing that you would notice there, it is upper and lower bounds. Anytime you see like nearest 5 kilograms, nearest 100 kilograms, or nearest to something, it's usually upper and lower bounds. So the first thing I want to look at for this one is this line here. So it says her van can carry is 1,500 kilograms measured to the nearest 100. What we would do there is we would half the 100. So that means that would be 50. So we add 50 to 1,500 and we take away 50 from 1,500. And that's what we have here. So we have the upper bound and the lower bound. If you took those two away, you'll find that that would be 100. So the next part of it is we want to find out what the upper and lower bound of the next one would be, this second line. So it says each container weighs 50 kilograms to the nearest 5 kilograms. So you can see it's nearest 5. So when it's nearest 5, you half the 5. So half of 5 is 2.5 or 2.5. So what we need to do is add 2.5 to 50 and take away 2.5 from 50. And what we should get is the upper and lower bound of the 50. So upper bound is 52.5 and the lower bound is 47.5. And if you took away those two, you would come out with 5 kilograms. Okay, so we now have this set up first. This is in when you do upper and lower bounds in your exams. It's always good practice to start off with the upper and lower bounds initially, so you have it all set up to answer the question. So the question says, what is the greatest possible number of containers that Pam can carry in her van? So what we need is, to get the maximum amount of containers, we need to have the upper bound of the load her van can carry. So the upper bound of her load the van can carry is 1,550, and the lower bound of the container, so this one here is 47.5. Now what you're aiming for here is, if you've got a fraction like that, is to get the biggest gap possible. So you're using it on top of the fraction, you're getting the upper bound of that and the lower bound, so the numbers are as far away as possible to maximize it. So when we look at this one here, we can see it's 1,550 divided by 47.5. When we put that into a calculator, we get 32.63157 and so on. But overall, we only need 32. So what is the greatest possible number of containers that Pam can carry in her van? It is 32 containers, because 0.6 is just too much. So 32 would be the greatest amount of containers that would fit into her van.